All right, let's continue on and finish up the book. It's going to talk about kind of a grab bag of different topics, really. Stable storage. All right, yeah, you want your storage to be stable. Of course you do. Okay. What this has to do is think of this as a tertiary storage device. And really, you have your secondary, which is your hard drive. Tertiary is for your long backups. A lot of systems have this. AWS calls this Glacier. The idea is that you're not going to use this information for a very long time. You just need it stored in case you need to get it retrieved. The way AWS does it, and by AWS is Amazon Web Services. I forgot about it's the cloud, Amazon's cloud. What they do is that if you do need it, you have to put in a special request and they'll go and retrieve it for you. It's not an instant retrieval. But the benefit of this is, you look at the Glacier policy, it is extremely cheap to store something in there. Usually it's built out of removable media because you're just going to do it and then store it, and hopefully you'll never need it again. But you want it just in case. I love how their first example was a floppy disk. Any of y'all, when was the last time y'all touched one of those? Don't answer that question. Did you do those when you still had those when you were a kid, or were they gone?
They barely had those. They had them with the ugly,
you went to the Navy first.
With the ugly tan computers.
I used it before I was in the Navy.
Yeah, exactly. That's what I'm trying to say. You don't say anything. I just want to know if the new kids ever had to use floppy disks anymore. You still use them?
I mean, last time I used it was like maybe second grade.
Second grade. Wow. All right.
Oregon Trail, man.
Oregon Trail, yeah. Apple II?
I don't know about that.
I will say I've actually
I wasn't old enough to know the computer system I was on.
Oh, wow. It didn't have the little dun, 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 dun when you turned it on? Y'all know
Normally
that?
the teacher had the computer on when you got there.
She didn't make you load it up yourself? Oh, yeah. She was like, put the disk in, type this in, I'll be back in 5 minutes.
And we could break it and bad things would happen.
All right. Anyways, you got floppy disk. That's okay, John. We got it. CD-ROMs. CD-ROMs. You'll probably use DVDs, Blu-ray, as well. Another type are available. All right, floppy disk. Wow. Most floppies hold a meg. I'm sure everyone is blown away by that huge amount of storage.
Wow.
It actually was a lot of storage when I was a little kid, so everyone keep your mouth shut. And then later on, they came with other floppy disks that go up to 1 gigabyte, and that was amazing. Although they were really slow. Obviously nowadays, CDs only go up to 700 megs. DVDs are what, 4.7 gigs?
I thought the floppy things they went up to like 720 the initial one.
720 gigs?
No, megs.
Megs, yeah. There was one that went up to 1 gig before it finally died. Blu-ray is what, 47 terabytes? Not terabytes, gigabytes, sorry. That would be awesome. All right, removable magnetic disks can be nearly as fast as hard drives, but they have a greater risk of damage from exposure. Yeah, in other words, floppies are bad, especially when you play with little magnetic disks, and yeah, because you can touch them. Yeah, it ends poorly.
Which is why our teachers wouldn't let us do it ourselves.
Wow, man, that was mean. She just didn't care.
Oh, one of the
No, she
first
did
things
care.
you
That was
didn't
the
get
problem.
all these-
That was the problem. Oh man. That's why you just have your little duplicator on the side, and you just keep duplicating the disk every time the kid touches it. Oh well.
Magneto?
I was trying not to say that word. Magneto? Okay, optic discs. AKA, this is what you're thinking about with DVDs and CDs and Blu-rays. So, Amplify was a large, weak magnetic field to record a bit, and then you can read it later. Right. They don't use magnetism, even though they have the word magneto on the top. I mean, magneto, whatever. They have special materials that can be altered by laser light. Hopefully they tell you more. Nope. Worm disks, terrible acronym. Write only, read many times. I don't know why there isn't a T in there. But you write to them once. Most CDs and DVDs are this.
DVD-R.
DVD-R, yeah, you got it. Write once and you're done. They end up being very durable unless you take a knife to them. Just personal experience, guys. Don't do that. Reliable as well, again, as long as you don't stab them. And they can come with data pre-recorded. These are actually pretty good, especially how cheap they are, because they're really just two glass or plastic platters with aluminum film in between. And you just play with them. Some of them seem to only have one plastic on the bottom and then the aluminum right on top. That always cracked me up. Really couldn't spend the money on the extra plastic on top. No, that's just way too much effort.
And business people.
Them business people.
Why are we spending extra? Listen, if they break it, they have to buy more.
All right, good old tapes. So you all remember the data tapes from the 60s.
Of course.
Of course.
Who doesn't?
Who doesn't remember the 60s, right? Compared to a disc, a tape is less expensive and holds more data. That is still technically true, although kind of going to the wayside. Random access is much slower. Again, why is that the case?
Because it has to
Sequential
Yeah, it's the sequential, right. Usually pretty economical. You'll have what's called a stacker system where you'll be able to stack multiple tapes and write to them all at the same time. It's really good for archival, but pretty much nothing else. The OS has to manage all these different devices. I just realized this chapter has nothing on solid state drives, which is kind of crazy. So you can give you the raw device, just an array of data blocks, or you can look at it from a file system, which then the OS takes care of actually scheduling it itself. In other words, raw, the OS ignores the problem. File system, it tries to implement it with FAT or NTFS or extension 4.
And they'll have it under future technology. It's in the chapter.
Oh, really?
Yeah, it says
Wow.
future technology.
Future technology? SSDs were out in 09.
Think of the future.
Thinking of the future, man.
So they're growing in importance and becoming more common.
Like communicators.
Yeah. Why have we got this little dial? Like, where are you? All right, most OSs handle removable disks same way as fixed disks. That's true. Tapes are really only present nowadays as a raw storage medium in the back end. Not used too much. Right, so for the tape backup, it usually just dumps it and calls it a day. And then the application will make up its own rules if it has to. Right, tape drives. All right, they're a little different. Located on what part of the tape, and then the read position, you can actually read from there. Usually tapes are append only. You updating a block in the middle of tape also effectively erases everything beyond that block. So really, they're only good for straight up backups. Okay, file naming can be difficult, mainly because you have different file systems. So for CDs, they try and standardize the file system. It's actually not FAT or NTFS. I forgot what it was called, like Juliet or something along those lines. So they have their own special file system for writing to it once. Oh yes, HSM, which stands for Hierarchical Storage Management, not Hardware Security Module, which is something different. I like how they got the word jukebox in here. So a system extends storage hierarchy beyond primary and secondary by incorporating ternary or tertiary storage as a jukebox of tapes or removable disks. Right, you just have a stack of disks, or as they like to call it, a jukebox. All right, speed, we got it. That's nice. Reliability, all right. Fixed disks, so this is where actual solid state drives kind of come in. Usually magnetic storage for reading and writing constantly for a prolonged period of time will have better reliability than a solid state drive. Also, a fixed disk drive is usually more reliable than a removable one, aka you're limiting the physical interaction with the disk drive. Yes.
For solid state, it's just write that deteriorates it, right?
Yeah. Well, it's actually erase. So the problem with solid state is there's now 3 operations. Beforehand there was read and write, but now there's 3 operations because before you can write to it, you have to erase it first. So it's read, and if you want to write to it, you have to first erase it and then write to it. So what actually happens in a solid state drive is they have all your data is being read, and then they have blocks that they have already erased. So when you write to something, you write to the erased block, because writing to an erased block super fast. Reading super fast. Erasing takes forever. So a lot of times, if you look in the old time, it was called the trim command, and basically once you wrote something and a block was not used, the disk drive would, once it has extra cycles available, it would start erasing that block.
But if you just stored stuff that was never going to be overwritten,
Yeah, you're fine. Yeah, you're fine. Although an optical disk will be a lot cheaper, just slower.
Yeah, the point is performance.
Sure. Sure. Well, right, what's your application?
Performance.
Performance of just read?
Operating system.
Oh, if you want performance of just read, then just implement a ROM. And
Like,
a ROM, remember the read-only memories where you have the different lines with the diodes that tell you which one's a
Sure.
one, which one? Yeah, that would be way faster and cheaper, takes up almost no space. But that's if you never want to write to it.
but you have to physically make it.
Well, you have to physically make a solid state drive as well.
Well, no, I can go buy a solid state drive and load my operating system onto it one time.
Right, because you can write to it.
Right.
Oh, so then you want what's called an EEPROM, which takes a long time to write to, but once you've written to it, yeah, it reads super fast. So there's different solutions. Nice segue. Let's see, or sidetrack. So optical is usually more reliable than magnetic disk because you may not. It's harder to mess up, although a knife still fixes that. Head crash in a fixed disk generally destroys the data, whereas failure of a tape drive or optical disk often leaves the data cartridge unharmed. Yeah. Just because your CD laser pointer breaks doesn't mean your disk is now destroyed. Unless it breaks and like jams right into it or something. But usually that's not what happens.
You should stop taking knives, then.
I know, I need to stop saying that. It's a good thing that's not a Title IX problem. Or whatever it's called.
It might be a police problem.
Police?
Depending on what you say.
That is true. I'm only talking about inanimate physical objects. So I'm good. I hope so. I'm good. So.
Until we have a DATA,
Oh, thanks.
data enforcement. Whatever it would be.
Cost. All right, main memory is more expensive than any disk storage. Wow, can we just see? Okay, here, good. We have pictures. Up to 2004, price per megabyte. And as it ends at 0.8 per megabyte in 2004. All right, great. Price per megabyte on magnetic disk drive, it's 0.001 per megabyte. So look at that huge difference, 0.8 to 0.01. So obviously your disk drive is way cheaper per capacity than your main memory. Of course, your main memory is way faster. And then tape. Wow, they make tape look terrible. 0.01 for. All right, I don't know what the deal is with this. But your tape drive generally is cheaper. Oh, and we're done. So solid state drives, which are pretty much everywhere, the big thing, keep in mind, I think I went through it with the erase, read and write. But yeah, they are faster for reading and writing to empty blocks. They do have wear level problems on them. From a security standpoint, it is an interesting situation. Let's say someone, if you think about it from a magnetic standpoint, and you're trying to magnetize, it's basically like a little blip that goes up and down. If you overwrite it and you erase it, is there any way to recover that data?
Yes. Have you fully gotten rid of the magnetic layers?
I'd say the initial data was that, low and high, just using it. This is just an example, just to give you an idea. When you write it, let's say you overwrote it with straight zeros, it may come out like this. The threshold's right here. So anything below that is 0. But if you look at it, it didn't go down all the way. So what happens is, and the NSA has done this, they will, after you have erased your whole hard drive, they will take the platter out, put it in a special machine that tries to decipher this little difference right here and try and rebuild your data. I'm not joking. They have done this before.
I can neither confirm nor deny.
Because your fluctuations are going to be very similar, almost a pattern.
There'll be a pattern to it.
So,
I can say government secured erasing techniques require that you erase your hard drive 7 times.
Right. And that's only if the data, and I can tell you this because it's public knowledge, if that hard drive is going to be reused for the same classification level. If it's going down to classification level, what do they have to do? They have to degauss it, which, well, usually means destroy. But there's other things they can do. But I just wanted to point this
you
out.
said degauss, right?
Degauss.
Okay.
There is a way to degauss this completely.
Put it in a very heavy magnetic field.
Right.
Big magnets. Spin it, guys.
And then it pretty much fixes this issue. They have not figured out how to degauss a solid state drive, so they always have to be destroyed. That was a big issue back when they really wanted to reuse hard drives because hard drives were expensive. Nowadays, they usually just destroy
There were
them.
also chips too. We used to keep so many different backup chips in the safe. You pull them out, and you're like, okay, take the hammer out, smash them in little pieces.
Yes.
Make sure it's powder.
Burn them.
Burn them.
Oh, burn them afterwards. Burn everything.
Yeah. I love how it had an NSA approved. What was it called? Destruction device. It was fun.
They say it was a trash can with your sledgehammer, your regular hammer, stuff to light stuff on fire, because that's what you use a trash can for. It was a kit. They just said you had to have all these things.
Yeah, I loved how after you broke it with a hammer, there's still more steps to do. That was always my
Yeah,
favorite.
because you can still recover. You can piece it back together,
I mean, yeah, sure, yes,
glue it together,
sure,
all
okay.
little pieces, and there may or may not have been people that did this. I can neither confirm nor deny.
Any other questions? Matt, you ready for your exam?
I'd rather not, but I guess.
Any questions about solid state security? Nothing?
Mm-mm.
All right, do we have any cybersecurity majors here?
I would like to have done that, but I didn't have the class conflicted or something. It was just really.
Okay.